Hi, this is Dr. Shoikat Majumdar. Under Basic Physics course of Diploma Engineering, we will discuss thermal expansion of solid. This is in Unit 3 of Heat and Thermodynamics under the submodule of 3.1. The learning objective is to understand thermal expansion and identify the factors affecting thermal expansion. Also to find out the change in dimension with the change in temperature and the relation between the different coefficients of thermal expansion in solids. Thermal expansion of solids. The phenomenon of expansion of a substance on heating is called thermal expansion. In general, all substances expand when heated and contract when cooled. However, for the same increase in temperature, expansion of solid is much less compared to the expansion of liquid and gases. This is how we can explain. Suppose this is a jar. We have taken liquid inside it. A thermometer is placed here. If it is heated, the temperature increases and the volume of the liquid increases. If it increases more, it will come out from this one with the temperature is increasing. This is the thermal expansion. So that I have already discussed thermal expansion. Now again to summarize, what is thermal expansion? Increase in size of any object like solid, liquid and gas on heating is called thermal expansion. So let us take this figure. This is the initial volume, its initial length is this. If temperature is increasing or heat is given onto it, the length increases to this dotted lines and the final volume becomes as the dotted lines. So that means its volume increases. Note, water shows an exceptional behavior. A given mass of water when heated from 0 degrees centigrade, instead of expansion, it contracts up to 4 degrees centigrade. Beyond 4 degrees centigrade, it expands like other liquids. This particular behavior of water from 0 degrees centigrade to 4 degrees centigrade is called anomalous expansion of water. So, very important point to remember, anomalous expansion of water. Another point to be noted, the expansion of an alloy of iron and nickel called invar with the rise in temperature is practically nil. That means if we take inverse, if temperature increases, then its expansion will be practically nil. So there are three types of thermal expansion. Number one is expansion of solids. Number two is expansion of liquids. And number three is expansion of gases. That means if we increase the temperature, the expansion from initial volume to final volume is the final expansion. So solid, liquid and gas, all these three materials will be expanded if heat is given onto these materials. Each of the materials having some coefficient of thermal expansion. We will discuss the expansion of solids. There are three types of expansions in solid. Number one, linear expansion. Number two, superficial expansion. Number three, cubical expansion. So let us discuss linear expansion. Consider this is the solid rod of length L0 at temperature T. Now the temperature is increased to T plus delta T. T plus delta T. So its length becomes L. So the relation between this final length to the initial length is L is equal to L0 1 plus alpha into delta T. Delta T is the difference between the initial and final temperature. So if we write the change in length L minus L0 as delta L, so this formula becomes delta L is equal to L0 alpha into delta T. So delta L by L0 is equal to alpha into delta T. Delta L by L0 is equal to alpha into delta T, where L is the real length, delta L is the change in length, delta T be the change in temperature, and alpha is the coefficient of linear expansion. Now we will discuss second point of expansion of solid, that is superficial expansion. In this figure, this is a thin sheet. If heat is given, its faces, that means the length of the faces will increase. So the area will increase. Let us consider at temperature T, the area is A0. That is the original area. Now the temperature becomes T plus delta T. The area becomes, say, A. So change in area is A minus A0, we are representing it as delta A. So delta A to A naught, it becomes beta into delta T. This beta is the coefficient of superficial expansion. Here A naught is the original area, delta A is the change in the area, delta T is the change in temperature, beta is the coefficient of superficial expansion. Now there is a relation between alpha and beta. Alpha is the coefficient of linear expansion and beta is the coefficient of superficial expansion. So alpha, the relation is alpha is equal to beta by 2. So we can write beta is equal to 2 alpha. So this formula becomes delta A by A naught is equal to 2 alpha delta T. So area expansion delta A to A naught is equal to 2 alpha delta T. Actually, this is to be mentioned, that is the change in surface in solid is directly proportional to the original surface area, and also change in surface area is proportional to the change in temperature. So if we write A minus A naught as a change in surface area, it is proportional to the original area A naught. Again, A minus A naught is proportional to T plus delta T minus T. Thus, we can write A minus A naught is equal to a constant of proportionality, that is beta, is equal to A naught delta T. Cubical expansion or volume expansion. If heat is given to the solid, all the sides of the length of the sides, that is the length of the body, will change or increase. With this increase, the volume will be expanded. Suppose this is the length. With the change or the increase in heat, this length increases, this length also increases, this is also increases. That means all in 3-dimensional lengths will increase, thus the volume will increase. It results the increase in volume. Consider a solid cube. So with the increase in temperature, the volume of the solid cube will increase. That's why it is known as cubical expansion. If we consider initially the volume is V naught, and at that time the temperature is T. If the temperature increases to T plus delta T, the volume becomes V. So change in volume V minus V naught, we are representing it as delta V, and the change in temperature is delta T. So delta V by V naught is equal to gamma delta T. V naught is the original volume or real volume, delta V is the change in volume, delta T is the change in temperature. Gamma here is the coefficient of cubical expansion. Now, again there is a relation between linear expansion and coefficient of cubical expansion. That means there is a relation between alpha and gamma, and the relation is alpha is equal to gamma by 3. So gamma becomes 3 alpha. So putting this value, gamma is equal to 3 alpha, the volume expansion delta V by V naught becomes 3 alpha delta T. Thus, the relation between coefficient of linear expansion, superficial expansion and volume expansion is alpha is equal to beta by 2 is equal to gamma by 3. Alpha is equal to beta by 2 is equal to gamma by 3. Few real life examples. This is the rails and there is a gap between the two rails. Everybody we have seen this during our travel through train. That means some space is left between the two rail tracks. Now, the temperature in different season is different. To cope with the expansion with different temperatures, this space is given between the two metallic blocks or metallic lines, metallic rods, so that with the increase in temperature, that means in summer season, they can expand freely and fill the space. Again, during cold, it will contract and it will not break the line, so that the service become undisrupted. We have seen the power transmission cables and lines. These are hanging like this between the two poles and transmission towers. The electric cables are loosely fixed to the electric pole, so as when during hot weather the conductor will expand and the cable will not cut down. That means if temperature increases, its length will increase, and again it will move towards this direction, That is, more hanging will be there. So the cable will not cut down. So there will be again undisrupted power. Iron railings which are present on the road of the overbridge. This gap are present so as to expand freely in summer, that means in hot weather. In hot weather, this metal will increase and fill the gap. Again in reduced temperature, this gap will be maintained. Now, some sums on thermal expansion. calculate the increase in length of brass rod which measures 220 centimeter at 10 degrees centigrade such that it is heated 950 degrees centigrade. Alpha means coefficient of thermal linear expansion for brass is 0.4018 per degree centigrade. Also calculate the overall length at 950 degrees centigrade. Given L0 is equal to 220 centimeters, alpha is equal to 0.4018 per degree centigrade, and change in temperature delta T is equal to 950 minus 10, that means 940 degrees centigrade. So increase in length, final length to initial length is equal to initial length L0 alpha into delta T. So 220 into 0.4018 into 940, it becomes 3.72 centimeter. So length at 950 centigrade, LT will be L0 plus change in length. So L0 is 220 plus 3.72, that means 223.72 centimeter. Second example, a brass rod 2 meter long, when heated through 80 degrees centigrade, increases in length by 3.2 millimeter. Calculate the coefficient of linear expansion of brass. That means we have to find out here alpha. Initially length is 2 meter. Increases the length, that means delta L becomes 3.2 millimeter. That means 3.2 10 to the power minus 3 meter. We know delta L by L0 is equal to alpha into delta T. What is the delta T? Heated through 80 degrees centigrade. This is the delta T. This is delta T. So alpha is the increase in length by original length into rise in temperature. So we can write increase in length means 3.2 10 to the power minus 3 by 2 is the original length into delta T, that means 80. So it becomes 0.402 per degree centigrade.